My name's Sam Cassett. I've been in this industry for a long time, and I've observed the various trust architectures that we have created over this period of time. From the earliest blockchains like Ethereum, I spent some time helping build a company called Consensus, which basically funded all the infrastructure around Ethereum. And now I'm working on this company called Layer, and we make a product called WAVS. WAVS stands for something much more complex sounding. It's WebAssembly System Interface Autonomous Verifiable Service. An autonomous verifiable service is, an AVS, which is the subject of our track today. So let me try to give a little bit more context here. So WAVS is about more than just sort of a set of tooling. It's more than just an AVS. It's more than a piece of architecture. It's really inviting us to look at the way that we can reimagine trust architectures in Web3 more generally. So it's about ultimately achieving the vision of Web3 because I think we've been stuck in this kind of local maximum where everyone that wants to build a chain tries to build a chain that does X, right? That works until it doesn't. That works until you reach up against the need to do high performance computation. It works until you bump up against the overloaded and extremely expensive cost of trust in something like an entire chain. When you look at how much emissions is required to make, to make the next chain link, or to make the next L1 in Cosmos, for instance, which sometimes pay like 100% inflation in order to secure that trust. It's not necessarily the right equilibrium. And so this is more about allowing a heterogeneous set of types of trust, and which is also kind of what EigenLayer has ushered in. It's also what the whole idea of restaking and AVSs has ushered in. But this is about sort of advancing the science and practice of that. So, there are a bunch of problems with just building a chain for X, right? There are a bunch of problems with just smart contracts for X. The amount of computation that's actually possible within each validator process is pretty low. Often those teams haven't really done any work to have access to things like GPUs, which are necessary for the next AI workloads. They often haven't really worked on scaling. It's good to see that now we have things like Mega ETH, for instance, which have scaled TPS. But really, it's not about TPS, right? TPS is kind of a misnomer. It's a marketing term. It really, it assumes that we're working in this architecture of playing DeFi games with each other, and that's the only thing that's relevant for us. Even though I spend a lot of time in the trenches of DeFi summer and we can play those games, ultimately, if we're really going to envision what Web3 promised back in 2015 when we were all thinking this was going to change the way that trust architectures work across the world, we need different kinds of compute. We need different kinds of architectures, and WAVS is an attempt to enable that. If you think about what the implication of that is, we are imagining right now, through EigenLayer, through AVSs in general, we're imagining how to pay for different trust architectures. So what do we pay for when we pay for instance, the governance system of the United States or of Dubai? We pay for police, we pay for the military, we pay for legislatures, we pay for the entire administrative burden of ensuring trust relationships so that I can create like a contractual relationship with you, and I know that that contractual relationship will be followed through. That's extremely expensive. If you imagine all those things combined for the entire world, that's how much we're paying as a civilization for that. But now we have a way, which was the promise of Web3 initially, to take those same trust assumptions, do them without violence, do them without the necessary burden of those entire administrative sets of structures. And what AVSs allow is a sort of transmutation of that trust at this only chain level to a different type of trust, where we are providing cryptoeconomic trust to a process, to an off-chain process, but in a totally different sense that allows for high-performance computation. So, put very simply, right, we're sort of at this precipice where we have all this cryptoeconomic security. This slide was made like a few weeks ago, unfortunately, for Ethereum. So actually the number's a little bit less right now, the total like Lido and our ETH combined. But there's all this sort of staked ETH that's not earning any other rewards. It's not being put to use as a type of cryptoeconomic trust for any other kind of any other kind of computation, any other kind of trust relationship. So in total, people are missing out on a tremendous amount of rewards. But what this needs to do is it needs to sort of find an equilibrium. We are at a place right now where even though there are many different types of places to stake this to, people aren't doing it. And why aren't they doing it? It's partially because the amount of rewards that's available is quite low. I think people are getting maybe an additional 0.8% on their ETH when they restake it right now versus just the native Ethereum staking amount. So what we will do, and what we're starting to do as we start building things, is we will have those streams of payment for that crypto economic trust start to increase. And as they increase, people will find, the market will find the right equilibrium between how much is that worth and how much are people willing to pay for it. Right now, if I make a new L1 chain, I need to choose some inflation amount for that chain, right? The total inflation amount, most people overshoot, right? If you have a chain paying 100% inflation per year, or even 15%, that's probably more than the total amount of trust necessary to secure the economic activity on that chain. But it's probably not also 0.01% either, right? But right now we're sort of in this, this calibrating sort of speculative state where people are building these things that require crypto economic trust, namely like AVSs. There's a very low amount of rewards going to them. But at the same time, that equilibrium hasn't been found. So what we want to do with WAVS is allow more and more AVSs to be built, enable rewards to be more ubiquitous, and allow basically the market to find that price of trust. These numbers I think are a little bit low. I think the number, you know, if you actually start at ideation, not just things that are kind of in test net phase and things that are live, there's actually about like 280 or so that are in development. So people I think dramatically underestimate how many builders want to build in this way. But the problem is twofold. There's a lot of coordination problem that you need to undertake in order to build an AVS. One of them has to do with operators, right? So if I need to build something, not only do I need to build the software, but I need to get, you know, at least 20, 30 independent validator companies essentially to run that software. So this takes months and months of business development time. You have to convince all of these people that run this infrastructure that it's worth their time and money to speculatively integrate your AVS. It's just a lot of work to do that. And you know, for a small startup, for a company that's just beginning this, it's a high barrier to entry. The other is integration logic, right? You know, we at Layer we love EigenLayer, but you know, when you take like the raw bare bones software that it sits on top of their crypto economic security, basically what you get is a Docker container, and then you're left to sort of do whatever you want. How do you integrate with the rest of Web3? How do you send transactions? How do you receive information from Web3? How do you interact with anything else on the web through APIs? You're kind of left to answer that question. So this, in total, makes a pretty high barrier to entry. We enable not only rewards, but we hope that is what sort of instigates the next generation of this. So this is kind of an architecture of what WAVS looks like. You can think of it as a set of triggers that are automatically already connected into a WASM-based runtime. So where it says WAVS there, it's basically a WASM runtime that is sitting on top of all these operator sets that we've already recruited. It's taking in those events, it's taking in signatures, it's doing coordination, and then that WASM runtime can be anything, right? It could be an AI agent, it could be a ZK prover, it could be something that has TEs available to it, it could have something with GPUs, and then those events trigger those components to run. Maybe it runs something on a TE. As soon as an ETH-L1 transaction happens, then it computes what to do about that through an AI agent that's running on WAVS. Then it can write it to OP stack. Then it can write something back to Ethereum. So it can create these sort of like composable flows of both triggers and information. You know, this is fundamentally a new kind of interstitial fabric that connects chains with this sort of high performance compute available platform that allows like new types of applications to be built. So part of the promise of Web3, I think, when we first started imagining what does it actually look like to start to reimagine the economic substrate of reality using Web3, we thought there would be all these applications. We sort of hand-waved it, and we said, well, you could build a decentralized Uber, or you could build a decentralized stock market. But what we didn't really consider was that maybe something that needs to reach consensus globally all the time wasn't really the right performance set to achieve that. We didn't really imagine maybe that we might need TEs or GPUs in that loop. And so this framework of WAVS kind of provides this generalized way to connect events. They could be on-chain events, they could be time-based events, they could be anything, and then actuate on any chain as well. So this is kind of just an example of those composable flows. This is kind of what I was saying before in terms of how a WAVS instance both runs and captures value. Normally, if you want to run an AVS, you kind of need to go negotiate with operators, find them, pitch them. Then each time you want to upgrade what you're doing, you need to not only upgrade this entire Docker container with an entire Linux distribution in it, but you also need to speak with each of them and say, at this block height, upgrade this Docker container to this this particular version. It's just a large coordination problem. However, with something like WAVS, you're just running this runtime. The operator's already running that. And if you want to upload something new, in milliseconds, you can send a new WASM component. It automatically runs, and it can hot swap out very, very quickly. How am I doing on time? Well, I'll just keep going. So I think this leads to a more flexible, lower cost thing for operators. For them, it's much more efficient. If you compare this to a Docker container, each of these components can be a megabyte, for instance. It runs at native speed. You can hot swap these things in and out. So you can imagine almost like a swarm of WASM-based components running this set of extensions called WASI, which lets you touch through the sandbox into the bare metal, and that basically is like running on the machine natively. What our hope is in this generally is that we take this sort of market of restaked ETH. It's a little smaller than that today, but I think soon it'll be back there and then higher. And we sort of expand the available amount of security that can secure all global transactions, things like the bounded behavior of AI agents, completely new markets that we haven't even imagined within Web3 yet. And we begin to consume and utilize the total amount of economic security that's available, which is in the trillions within Web3, and keep going. So another aim of what we're doing here is just to, by lowering the barrier of entry dramatically, without something like WAVS, with just the crypto economic security layer, you are progressing at a certain speed. But when you look at, for instance, like Nader from Eigen has a great video on Twitter/X where he goes from looking at documentation to building a full AVS in 13 minutes. Our hope is that we create this delta and that we can dramatically increase the experimentation speed with which people can build this, and therefore dramatically increase the speed at which we find this economic equilibrium where we find the price of trust. We more efficiently utilize that trust, and then that contributes globally to the way that we build everything and finally realize the vision of Web3. So that's pretty much it. Our developer community is pretty active. You can go to wavs.xyz or layer.xyz. There are very active documentation things there. If you want, we can add you to groups where you can learn about this. And people are building lots of stuff, including AI agents, oracles. It becomes very trivial to build a lot of the things that normally take an entire chain to build in Web3. So thanks so much.